Today we are going to start with a very important chapter of physical chemistry, that is stoichiometry. Now stoichiometry basically involves the mole concept, different types of strength of solution, normality, molarity, and their related problems. To make stoichiometry easier to you, we divide stoichiometry into two parts: gravimetric analysis and volumetric analysis. When we say gravimetric analysis, there is no clear-cut distinction between gravimetric and volumetric as on date, but to make things clear to you, gravimetric analysis basically involves taking the substance in the very state that is given to you. For example, if a solid is given to you, we'll use the solid as my reference material. Whereas in volumetric analysis, whatever solid or sample is given to you, we dissolve them in water and form a solution, and with that solution we carry out the reaction. So in volumetric, a compound has to be dissolved in water to prepare a solution, while in gravimetric we can start with the material as given to us. Now gravimetric analysis again divided into three parts. One is called weight-weight relationship, one is weight-volume, and one is volume-volume. It basically means that suppose I have a reaction, A gives you B. If both the substances are solid, then they may ask you to produce 10 grams of B. How much A do I need? How much means the amount. The amount can be in grams, in volume, whatever. But if A is a solid, then we calculate the amount in either mole or gram. That means B is also in weight, A is also in weight. We call it as a weight-weight relationship. Now tomorrow it may so happen that a solid gives you a gas B. Now as B is a gas, we can calculate its amount in terms of volume, provided pressure and temperature is given to us. That means A is a solid. In order to produce a definite amount of B, how much A do I need? So from a solid, that is a weight, we are calculating the volume of B. So this is called weight-volume relationship. And lastly, we have the volume-volume relationship. For example, hydrogen plus oxygen reacts with each other under a particular condition to form water. Now this hydrogen and oxygen both are gas. Water can either be a gas or a liquid depending on temperature. If temperature is very high, then water has to be a gas. So here if I ask you, in order to produce 36 grams of steam, how much hydrogen do I need? That means as hydrogen is a gas, its amount will also be reported in volume, and this is also in volume. Not grams rather, let's speak of cc here. So if this is cc and this is also cc, both are volume, we call it as a volume-volume relationship. So before we pass on to the gravimetric part, there are certain key definitions or key terms with which we should be familiar. The first one is the definition of mole. Now, we may be familiar with the mathematical definition of mole, but mole is defined as that amount of substance that contains as many molecules or atoms or ions as there are atoms in 12 grams of C12 isotope. This is a standard definition of a mole. That is, in 12 grams of a C12 isotope, whatever may be the number of atoms, that atoms is present in a definite part of my compound or atom or molecule. That means basically we mean to say in 12 grams how many atoms are present. If we know it, that atoms is present in a definite weight of my substance, and that substance is called 1 mole. And we write it mathematically, mole is equal to weight of the substance divided by molecular weight. In this regard, we have another important term called Avogadro number. Avogadro number, we are all familiar with the value, but it defines as the number of atoms or molecules present in 1 gram atom or 1 gram mole of a substance, which is equal to 6.022 or 23 as it is written in books, into 10 to the power 23. So number of moles can also be calculated from Avogadro number, because as per the definition, 6.023 into 10 to the power 23 molecules is present in 1 mole. So if somebody gives me 10 to the power 3 molecules are present and we have to calculate the mole, so we should divide 10 to the power 3 by Avogadro number. And basically we can say number of moles is equal to number of molecules or atoms, whatever you say, divided by Avogadro number. And finally, the last term which has got significance is the molar volume. Now, specifically molar volume means the volume occupied by 1 mole per substance. And if we calculate that volume at NTP, for 1 mole it has been observed that irrespective of the nature of the compound, 1 mole of any gas at NTP occupies 22.4 liters. So these are the very basic definitions with which we should be familiar. Now let us look at a problem based on this gravimetric analysis. As the question is written over here, it stands like this. Calculate the mass of oxygen required to combine with magnesium to produce 40 grams of magnesium oxide. That means the relation is between magnesium, oxygen and magnesium oxide. So whatever may be my reactant, in order to find out an unknown quantity, the relation between the three should be first of all written, which we write as the chemical reaction. But to satisfy the product on both the sides, the number of atoms on both the sides, we balance it. So the balanced chemical equation is this. Now these coefficients which you have written on the left hand side, 2, 1, 2, they basically indicate the molar ratios in which they are react. And the molar ratios of the compounds reacting in a given chemical reaction is always the same. So atomic weight of magnesium in 24, we can clearly say 2 moles of magnesium reacts with 1 mole of oxygen to produce 2 moles of magnesium oxide. Now 2 moles of magnesium oxide basically corresponds to how much weight? 2 into 40. 40 comes out to be 24 plus 16. That means in order to produce 80 grams of magnesium oxide, the amount of oxygen required is 1 mole of 32 grams. But I have been asked to produce how much? Not 80, but 40. That is half of it. So if 80 grams of magnesium oxide are produced by 32 grams of oxygen, we can easily calculate the amount of oxygen when 40 grams needs to be produced. That is half of it, exactly 16. So the answer comes out to be 16. Now one important thing one should note down. In case of magnesium, the amount, had they asked you the amount of magnesium also, that also we can calculate very readily. How? Atomic weight of magnesium is 24, so 48 grams produces 80. So in order to produce 40, I need half of it, that is 24. But the amount of magnesium is reported either in moles or in grams because it's a solid. But for oxygen, the problem is manifold because oxygen being a gas, its amount can be written in mole. That means 16 grams is equal to half mole. This is also my correct answer. In terms of weight is 16, that is also perfectly right. And as it is a gas, therefore, its amount can also be written in volume. And the volume can be calculated from the equation PV is equal to nRT. That means if temperature, pressure is given to us, R is known, moles we have calculated, we can calculate the volume. So in the exam, you should be careful that whenever an amount of gas is asked, we can report it either in mole, weight or volume. And for volume, temperature and pressure must be given because volume is dependent on temperature and pressure, but mole and weight are independent of temperature and pressure. And to make problems simple, they can also give you the condition of NTP. That is, they may ask you, calculate the amount of oxygen evolved in cc or in liters at NTP. So 1 mole occupies 22.4 liters, half a mole will occupy 11.2 liters. There we don't have to put it in the equation, directly we can solve it by using the 22.4 liter relationship. Now another problem of this kind, this is involving ammonia. Here is written that in order to produce ammonia, we all know nitrogen and hydrogen should combine in a definite molar ratio, which comes out to be 1:3.